And welcome. We are going to go ahead and dive right into looking at a lot more things with programming. We have, of course, seen how to do some simple print line statements to go ahead and output things. But those, of course, are creating pretty much a statically assigned thing that we want to print out every time. What if we want to make it where we can get to the point of someone typing something in? Well, there's going to be some things we have to do first before we kind of get to that point. And in order for us to do that, we first need to introduce the concept of variables to help us with our code. So diving right in, what is a variable? Well, you might have heard of the expression of a variable because if you recall in math, particularly in algebra, we kind of know what a variable is. It's simply just representing an unknown value. Well, in programming, a variable means roughly kind of the same thing in theory. A variable in programming is going to represent a data value. Now, that data value may or may not be known depending on the context, but generally speaking, we are not necessarily as going to see what that value is right off the bat. Now, variables should have a meaningful name. All right. In math, we can go ahead and just say, this is variable X, variable Y, N, M, whatever it is. But in programming, we create what are known as appropriate meaningful names following sets of rules depending upon the programming language that we're working with. Now, how do we actually go about creating a variable then if we can't just call it X, Y, and Z? Well, here's an example of things as we start looking at these different rule sets. The first thing you need to know is that variables are going to follow a very basic naming rule. The type, the name, equals a value. So again, type, name, equals value. If you can remember that, you'll be good. So what do each of these components actually do within inside a variable? Well, the type is simply the type of the variable. So is it a number? Is it a string? Is it some other thing that's going to be used by the program? What is the name? Well, the name is just what we're calling that variable. It's literally just the name of it. So it could be something like X, which of course we already said is not that really meaningful or helpful, or be something like count, which might have a little bit more meaning because it actually represents something. And of course, value is simply the value of the variable or whatever that variable is set equal to. So those three components are the core thing of what a variable is. Now, the thing you need to remember about variables is that we have to do two things with them. We have to declare them to some kind of type here. So we got to set them up. And then we have to initialize them. And those two things have to be typically used somewhere within our code in order for us to actually use whatever value we've created. So let's start with the first part, declaring a variable. So when we declare a variable, the big thing here to remember is that it has to be done within your program before we can use it anywhere else. So if, for example, if I were to say like int amount of cereal, well, that is declaring the variable. Or if I say like double, one weight, total weight. Again, these are just declaration statements. We haven't actually set it to a value. That's what initializing will do, and we'll look at that in a minute. But with a declaring, we're simply just making it exist. Now, as mentioned, variables have differing types. So, for example, we can see above we have an int and we have double. Well, int is used for whole numbers, positive or negative. We use double for decimal or floating point numbers. And these are things that we're going to see pretty common as we start moving throughout this course. Now, we can declare more than one variable of the same type using commas to separate the names. And we see that above with double one weight, comma, total weight. But here's another example. Int number 1, comma, number 2. What that tells the programming language, in this case Java, is that number 2 is the same type as number 1 because it's on the same line of code. When we see this semicolon here, that means this is the end of that line. And so when Java looks at this, it sees int, okay, well that is what type number 1 is, and because it sees this comma and it has not yet seen a semicolon, it's going to go ahead and infer that number 2 is also going to be an int. Now, I've already mentioned that we have different types, particularly what we're working with right now are what known as primitive types. Now, there are other types of variables which are more like called class types, but we will deal with those later. We're just going to focus on the primitives as they are the most basic type, and they're a good way for us to kind of introduce and get used to working with variables. And so in this table here, I have a bunch of different variables that we can use. So we have booleans, or sometimes they're known as bools. These represent true or false values. So if you were to have a boolean, let's say like is positive, it would evaluate to true or false. And in terms of memory, this is not something you need to know as much, but a Boolean is one of the smallest ones because it's 1 byte because it literally just represents true or false. We have chars, which are a single Unicode character. So like the letter A, let's say lowercase, would be a single Unicode character. If I had an uppercase A, that would be a different one. And again, those use 2 bytes. We have ints, I've already mentioned, those are integers. Those are 4 bytes. You have floats, also 4 bytes. Those are floating point numbers. Floating point numbers, remember, are decimals. We have longs, which are an integer. They're just really big integers that you might have to deal with. And those are 8 bytes. And we have doubles, which are, again, decimal numbers, 8 bytes. Now, when we actually start getting into our variables, we have to have identifiers for these. And the identifiers are simply just a fancy way of saying, what is the name? What are we calling this? So in Java, variable names cannot start with a digit, and the characters in the name must either be letters, digits, or an underscore symbol. We can't use things that are going to be, for example, spaced out. So for example, here's some just quick variable names: xx1, abcb, abc123, a underscore b. Now, as I've mentioned previously, these are not meaningful names. They don't actually carry much value to us as a programmer. All right, and so therefore they're considered poor choices for identifiers because they're not descriptive of what they're being used for. Variable names, again, should be meaningful and they should reflect what it is the program is doing. So let's just say I want to keep track of the number of occurrences within a program. Maybe I'm, counting something. Well, if I'm counting something, I can create a variable called count, and that would be a very appropriate name for that variable. Another thing to keep in mind as we start working on creating our names for our variables is case sensitivity. Java is very case sensitive, which means it treats upper and lower case as different characters. So for example, an uppercase A is different from a lowercase a. The words rate with all caps and rate, which is a capital R, and rate with the lowercase, there's all different variables because, again, if you look at the casing, they're all different. However, one thing to keep in mind, this is kind of a bad idea to name your variables this way because as the programmer, it could be confusing. Well, which rate are you talking about? So what we do instead is we use a convention called camel casing. And what that says is, hey, take the first word, make that lowercase, and each successive word capitalize it. And of course, we don't use spaces in between them. So for example, top speed, bank rate 1, time of arrival. This camel casing is a nice way for us to be consistent with their variable naming while following what's generally considered the accepted practice. Now, keywords are special words. So we can't name our variables anything we want. As I've already mentioned, one of the things we have to identify variables with a name that matches the purpose. And keywords, or as they're sometimes known as reserved words, are words that are used by Java that already have a predefined meaning. So it means if I were to use one of these keywords and try to use it as a variable, I would probably get an error because Java says, hey, I'm already using this. So because we can't use them as variables, what does that mean? Well, that means that we're going to have to avoid naming our variables this. So things like null, things like break, public, static, these are all reserved words that Java is using that we as the programmer cannot give our variables as a name. Now, the last step, if you remember, is equals a value when we're creating a variable. So assigning those variable values, we have to use what's called an assignment statement. In Java, the equal sign is used as the assignment operator. So, type name equals a value. And of course, here's some quick examples. I say total weight equals first weight plus second weight. Temperature equals 90.6. Count equals count plus 2. These are all examples of variables being assigned. Now, there are other assignment statements that we can look at besides just a straight up equals, but we're going to look at those at a later time when we can dive deeper into those. Now, there's one last thing, which is initializing of variables. Remember, we said we could declare and initialize variables. So what happens if I just write int number semicolon? All right, and I don't give it a value. It will compile fine in my code. I won't get any errors. But what does that mean in terms of how that's going to actually work in my program? Well, the variable's been declared, but it's uninitialized, meaning it has no value. Now, no value does not mean that it's set to 0. It simply just means it has nothing assigned to it. Now, generally, we want to give our variable a starting value. Now, note there are exceptions to this when we can look at this later, but generally speaking, we're going to get initialized to something. So for example, a number might initialize to 1 or it might initialize to 0, depending on how we want our program to function. So here's some quick examples. Int count equals 1, double speed equals 65.5, char grade equals quote A, int initial count equals 50, comma final count. Now if you look at this one, initial count is initialized, but if we look at final count, is final count initialized? You will notice this one is not. And I wanted to put this example here because this shows that we can initialize a variable, but we don't necessarily have to initialize every variable within that same line. Now, we can initialize within a declaration. We can see some of this already coming, how we can roll all this together in one line. Remember our format, type name equals value. If we follow this format, we're actually declaring and initializing our variable in a single line of code, which is really helpful. This is highly valuable to save us time and code as the variable is created within a single line. So instead of writing int number, semicolon, number equals 2, semicolon, we can instead write int number equals 2. So this is nothing like really kind of strange, but it's a nice reinforcement to show us that, hey, this is a good practice for us to follow. All right, and so real quick, I'm just going to give you a couple quick examples in Eclipse of how I can go ahead and create some variables. So I'm going to create a int variable, and let's just call this number. And I'm going to go ahead and set that equal to, let's say, 1. Now, if you notice, it's no longer yelling at me because I've set it to a value. Now, I can, of course, create another int down here, and it will not, if I just hit a semicolon, it's not going to complain about it. See, just declaring that variable won't do anything. All right, but if I were to try to output this, so systemout.println, if I do number, you will see when I go ahead and run this, that it just prints out 1. But if I change this from number to num, and I rerun it, oh, we have an error here. Oh no, why is that? Well, it's because we didn't initialize num to anything. So I would have to initialize this to some kind of value. And if I try to make this something like 0.5, you'll see we take care of this error here because it has a value, but 0.5 is a decimal, so I cannot go ahead and assign this here. So instead I want to make this, let's say 0, and you can see now it is nice and happy. Now, if you get a squiggle like this yellow one right here, see it says number has a warning, it's simply just because we haven't used that variable anywhere within our program. So if I were to have, for example, now add another print line statement and I put number in here, you will notice that that squiggle has gone away. Now, one other thing I want to show you is that if you notice in our print line statements, when we do our variables, notice there's no quotations around the variable itself. All right, that's very important to note because when we saw this with our previous things, anything I want to print out, I had to put in quotations. With variables, you don't put quotations around this because if I put quotations around number, for example, instead of printing out the value of 1, let's see what it actually prints out. It prints out the word number, which of course is not what we want. Now, one last thing is if I go ahead and say number equals, let's say 2, this is a assignment statement. And let's go ahead and remove the quotes here because we want this actually to print out number. If I were to do something like this and I were to run my code, you'll see that it takes whatever the most recent value of number that I assigned here. Because even though I only have to declare a variable once, I can come in here and create as many assignment statements as I want. In fact, I can come here after num is declared and say number equals, let's say 10. And if I run my program again, you'll see it now displays 10. All right, and so that gives us a nice good starting point for variables that we can then use to go ahead and create